Continuing the idea of factoring like we discussed in class, we will tackle number 6 the same way. You will notice that the denominator of number 6 can be factored easily, but the top of z minus 5 will remain. So, because we are factoring, we are going to write limit as z approaches 5, z minus 5, all over. The bottom factors into z minus 5 times z minus 5. One of the z minus 5s will reduce, leaving you with the other z minus 5. So your new problem is limit as z approaches 5, 1 over z minus 5. Now you can go ahead and plug it in. When you plug in the value of 5, you will notice that you will get 1 over 5 minus 5, which is again 1 over 0. This does not solve the problem. And because this is a result of after you factoring the problem, you can now safely say that a limit does not exist. Now we will look at numbers 7, 8, and 9. Numbers 7, 8, and 9 are asking you for the various limits from different directions. Part A coming from the left, part B coming from the right, and part C the limit at that value itself. In these problems, it is best to graph the function. Now, if you don't know these parent functions, like in number 7, it should be a new function to you. My suggestion would be to create a t-table, plug in a few numbers before and after the value that it wants to see the behavior of the function. For example, in number 7, the value is -5. I would suggest you create a t-table for the values -3, -4, -6, and -7 to see what the behavior of the graph would be approaching that -5. So let's go ahead and make a t-table. -7, -6, -4, -3. When you plug in -7 in here, you get -7 plus 5, which is -2. -2 over an absolute value of -2, making it -2 over +2. Your final answer is -1. Same should result for -6. You plug in -6 plus 5, you get -1 over absolute value of -1, so -1 over +1, again, -1. What happens when you plug in -4? When you plug in -4, you get +1 over absolute value of +1, so you get 1. And you'll get the same result when you plug in -3. So what happens? At -5, the value does not exist because you get 0 over 0. And if you graph the function, -1, 2, 3, 4, 5, -7 should be right about here. You get -1, -6 you get -1, and then at -4 you get +1, -3 you get +1. There is a clear break here at -5. The value does not exist coming from the right or coming from the left. This is what the function would look like. Hence, when you answer the question to part A, part B, part C, the graph is clearly defined. In part A, you have x approaches -5 from the left. So you're answering this based on the graph itself. Part A, limit as x approaches -5 from the left of f of x. Well, coming from the left, you will get -1. Part B, limit as x approaches -5 from the positive side, from the right-hand side of f of x is equal to +1. Because coming from the right-hand side, it is going towards +1. What about limit itself at -5? Well, because both sides are approaching different numbers, then the limit itself at -5 does not exist.